All right, so today we're going to take a look at section 7.3. Okay, section 7.3 is on solving trig equations and inequalities graphically. We are going to get into solving trig equations algebraically, but unless the trig equation is set up a certain way, it's not too complicated, solving it algebraically can be pretty hard. There's some trig problems that look kind of like quadratic problems, kind of like if you had sine x squared plus sine x plus 2. That's a quadratic type of problem because you've got something squared, then the something, and then a constant at the end. And it's all the same trig function. This is something we could solve with the quadratic formula, okay? Where a would be 1, b would be 1, c would be 2. You fill it in. The only difference is you're not solving for x, you're solving for sine x. So the last step involves one little extra thing. Okay, for today, we're not going to focus on doing things algebraically. Okay, purely graphically. Okay. And the idea when you're solving graphically, you have to find all the solutions in one period first. Okay, so you've got to know how to set your window to a width of one period. Okay, in this section, I don't think it's overly important if you cut off a period and it kind of starts like with secant or cosecant. If you've got a window that does something like this, like that, and like that, that's okay. You know, if you wanted to make it nice, you could try to show a full U shape and a full N shape in one window. But if it cuts off, it's not overly important in this section. Okay, and then once we find all the solutions in one period, we find all the solutions by taking into account the period. Right? So that just means put either plus 2 pi n or plus pi n if you're in radians. Or if you're working in degrees, you put plus 180 or plus 360 n. Most of the time. Okay, you can have periods other than 2 pi and pi. Okay, but those seem to come up quite a bit. Right, so we've done this algebraically. If I was going to do it algebraically, I'd take the inverse sine of both sides. I would get one answer, which would be in quadrant 1. And then that would be my reference angle. And where would be the other quadrant where sine is positive? Yep.
Quadrant 2.
It would be quadrant 2. So I'd take my first answer, and I'd do pi minus that answer. Right? That's what you did in the homework last night, and I think we did a couple today. Okay. Since this section is on doing it graphically, that's the approach we'll take today. Right? So how would I solve this graphically? It's actually a couple ways we could do it. Yep.
Do sine of x and then on our line see where 0.8 crosses it.
All right, so yep, sine of x and y1. Yep.
Is another one to 0.8?
Yep, put 0.8 and y2 and see where they cross. Okay, the other way you could do it is you could put everything on one side and now it's equal to what? 0. And now you wouldn't have to calculate an intersect. What would you be calculating in this one? A 0 or a root. Okay, so if you want to bring everything to one side, get it equal to 0, you can. When we solve algebraically, that's definitely how we have to do it. But for this section, you can do it just like we have here. What's my period for sine? 2 pi. So this window is going to work fine. I don't think the y min and max need to be that big. What would be good values for those?
2, -2.
Yeah, let's say -2 to 2. Okay, and remember, we are in radians. Okay, and here's our two answers. Okay, we already know the quadrants they should be in. Quadrant 1, so it should be between 0 and 1.57, and quadrant 2, so between 1.57 and 3.14. All right, let's do the first one. Okay, that fits first quadrant, 0.93. And does anybody have that second intersection point? 2.214. 214. So we'll round down. Okay, and what do I need to put on the end of both of those?
Plus 2 pi n.
Plus 2 pi n. Plus 2 pi n. And just make sure we remember what's n? Any integer. So that's the abbreviation for an integer.
It's a double Z.
Right.
I just don't know. What's the name of that?
It's the symbol for the set of integers. No, that's all I got for you. So this just means that you're going to see this answer at 0.93. You're going to see the same answer again the next period over if you add 6.28. Same thing here. This answer will occur at the next period over by plus 6.28. Okay? And that it occurs forever.
If they give you a certain window to look in, do you have to add the 2 pi n?
No. If they give you a certain window, they'll say find all answers between 0 and 2 pi. If they do that, you do not add the 2 pi n. Only if they say find all. Okay? All right, so the way I showed you, you could have set it up. If you set it equal to 0, you're finding the roots, okay? Or you're finding the zeros of the equation. Right? And if you're solving, when you have a function that's periodic, okay, so any trig function is periodic, when you get it equal to 0, you're really solving what's called a periodic equation, which means that your equation is going to have infinitely many answers because one of the terms in it is it's a periodic function. So one of the terms could be like sine, cosine, tangent. Okay, not every function is periodic, like y equals x squared. It's just a parabola. That's not a periodic equation. Right, so this part, you guys really already have this right-hand side in your notes. It's just a reminder. So let's say you have n solutions, okay, in one period. You have to write down every solution. It could be 2, could be 3, could be 1. Write down every solution in one period, and then put plus the period times n, just like we did in the first example. Okay, so when they ask you to write all solutions, put all the solutions you find in one period plus period times n. Okay, that's what we've been doing all along. All right, so now we're going to look at equations and trig functions that are more complex, okay, higher powers, like sine squared, sine cubed, things like that. So if you have an equation, right, and you have multiple terms in it that are periodic, the first thing you want to do is find the period of each term. Right? So like in this example, we'll find the period of cosine squared. Then we'll find the period of sine. After you find the period of each periodic term, the least common multiple of those periods, right, is the period of that whole thing. Okay, so you find the period of each periodic term and then take the least common multiple. And that's the period of the entire problem. Okay, so if, let's say one of them had a period of pi, the other one had a period of 2 pi, the least common multiple of those is 2 pi. All right, so eventually we're going to come up with a system that, if you know your trig function, bless you, and you know your power, you can figure out the period very easily. To start with, though, we're just going to kind of experiment. We'll make a picture of cosine squared and just look at the screen and see if we can figure out the period. Does everyone have what's on the left?
I don't know, probably not.
All right, so let's graph cosine squared. Okay, the way you write cosine squared on paper is like that. Okay, but we can't really type it in that way on the calculator. Okay, if you want to type in cosine squared, we need to type in cosine of x squared. Okay, now the reason I put those double parentheses is because I want to make sure it takes the whole cosine and squares it. I don't want it to do this. I don't want the cosine of x squared. I want the cosine of x square the whole thing. Okay, any questions on how I type that in? All right, now our window is set from 0 to 2 pi. Let's sketch it and see what happens. Well, before we sketch it, what kind of number do you get when you square something? Or think about what kind of numbers it's impossible to get when you square them. Yep.
It's impossible to get negatives.
Yeah, you'll never get negatives. All right, so this graph should be completely above the y-axis. All right, so there's the graph of cosine squared. How many times does it look like it repeats on the screen there? It's repeating twice. Starts here. There's 1. There's 2. So if my window is from 0 to 2 pi, and we're seeing 2 periods in that window, what do you think the period of cosine squared is? Pi. Yep. You could stop at pi right there, and you would see 1 full period. Okay. Now, what's the period of sine? Yeah. 2 pi. So what's the period of the entire problem? Yeah. No, pi is not the least common multiple of 1 pi and 2 pi. If you get stuck, think of what's the least common multiple of 1 and 2. The smallest number you can think of, they both divide into without a remainder. 2. Okay? 2 is the least, like write down your multiples of 1. 1, 2, 3, 4. Okay, write down your multiples of 2. What's the smallest multiple that's in both lists? 2. Or in this case, 2 pi. Okay? So your least common multiple, let's write it this way. Okay, what that tells me is what I should set my window for. Okay, the difference between x min and x max should be 2 pi. Okay, if I do that, I'll see 1 full period on the screen. All right, now we need to type in the whole thing. I don't want that. All right, so we got 2 cosine x squared, okay, plus sine of x plus 1. Okay, and my window is already set from 0 to 2 pi, so that's fine. Right, I do think I need to set the height, okay, a little bit higher. So let's go, let's just try that. Well, we could figure out what the highest value it could ever be is. Okay, what's the biggest value cosine ever gets? 1. And if you square that,
1.
and if you double it,
2.
2. So 2. And the highest value sine could ever be?
1.
1. So the highest this graph should really ever go is 3. Okay, I don't think there's any way. Oh, plus 1. So 4. So yeah, it could hit 4. Shouldn't go any higher than 4 though. Okay, if it even ever hits. Okay, so there's our graph. Okay, that's not it. There's our graph. Oh, I got it. There you go. All right. So now they want to know where this graph is hitting 0. So what I would do is check very carefully around here. There could be how many answers?
2.
There could be 2. I wanted to see a full picture first. I can see it's not going to hit 0 anywhere else. Now I'm just going to zoom. I want to do zoom 2. I think I have to sketch it again. Okay, so I messed up my window a little bit, but that's fine. Just try to zoom in. Just try to get over there somewhere. Kind of close. And it looks like, yeah, it looks like it's just 1, unless it's unless it's extremely close where it crosses. But I think you're right. I think it is just 1. Yeah, I think it is 2. Right? So let's try left. Make sure y goes negative, or it's not. If y doesn't go negative, then it's not. That's just about 0. That's still not negative. It's pretty close to 0. I mean, it's all right. That's as close as it got. So you know what? I think it is just once. All right.
Just hugs that one.
It looked like it could have been 2, but yeah, it actually just barely hits it right in the middle. So, yeah. Okay, so we get x equals 4.71. Plus, what's the period? 2 pi, and then put the n. Okay. Now, you might, 4.71, that comes up a lot, so you might recognize that number. It's 3 pi over 2. 4.71. Okay. For that one, you don't have to recognize it, and usually it's going to be a decimal that even I won't recognize. Okay. But if I see 1.57, 3.14, or 4.71, I know those are 0, 90, 180, 270. Okay, any questions on that one? All right, let's take a look at this one. Okay, so this one you've got 2 choices how you could solve it. We could do it like the last one. Put everything on one side, get it equal to 0, and calculate our roots. Or we could put something in y1, something in y2, and see where they cross. If you put something in y1 and y2, you're not really seeing a picture of the actual graph. You're seeing the left side separate, the right side separate, and you're just looking where they cross. If you want to get an actual picture of what this looks like, the whole thing, move everything to one side. Okay, so let's do it that way. Okay, what could I do to get everything on one side here? You could subtract tangent, or you could subtract the 3 cosine x. It doesn't matter. Right, now when we type that in, we're going to get an actual picture of what this looks like. But before we type it in, I need to know the period, which is going to help me set my window. What's the period of cosine x? 2 pi. What's the period of tangent? So what's the LCM here? All right, so now I know what I should set my window for to see one full period. Set it 0 to 2 pi. Okay, how high and low is this graph going to go? Yeah, because of tangent, remember, when you start getting close to pi over 2 and you take the tangent, tangent heads towards infinity. So you're going to take a number that's between, 3 cosine x is always between -3 and 3, and subtract a huge number. So this graph is going to have asymptotes. Okay, so range, I might just do the standard range. Okay, -10 to 10. Now let's type it in. So 3 cosine x minus tangent x. And it should end right where it started. Okay, so if I were to basically take this graph, okay, I can't really do it exactly, but if I took another copy and put it right next to it, and it didn't have a border, it would pick up right where the last one ended. Okay. Right, so there's our graph. And how many solutions do we have per period this time?
2.
2. Okay, we need to find both and write them down. Okay, I'll do the second one where it's curving downward. If somebody can do the root that's closer to 0, that would be good. Okay, so 2.13. And the period was 2 pi, so let's add that on the end. Okay, and anybody have the first point?
1.01.
What is it?
1.01.
1.01. Okay. Any questions on that one? Okay, and keep in mind, you can do this in degrees or radians. Okay, if I was doing degrees, I'd have 360n, and I would have set my window 0 to 360. Okay, and these two numbers, 1.01 and 2.13, would be different. All right, let's try this one. This one says 3 sine cubed 2x minus 2 cosine x. All right, so a couple things happening here. One, cubing it is going to change the period, but putting a 2 here also changes the period. All right, so let's graph sine cubed. See if we can figure out the period of that, and then if we can, we should know what putting a 2 here does horizontally to it. Okay, let's try sine cubed. Okay, I'm going to set my window, I think y min and max, -2 to 2 should be fine, because you're just cubing values between 1 and -1. So that should work. And let's just remember that our window is 2 pi units wide. Okay, we'll use that to help us figure out what the period is. Okay. Does it look like we're seeing it repeat more than once in that window?
No.
No. And in fact, if you wanted to double check, instead of going to 2 pi, go to 4 pi. And we would expect to see it how many times here? We should see it twice. If we do, then we know the period is 2 pi. And we do. Okay? So there's the first one and the second one. Okay, so the period of sine cubed is 2 pi. Right, so I'm going to set that back so we only see one period. And now, what does putting a 2 in there do? Yeah, it's going to compress it. So it's going to make the period shorter. So it was 2 pi. What do you think it's going to be now?
Pi.
It's going to compress it down to pi, which means I'm going to see it twice in this window. Or I should. Okay, and I do. All right. So now, in a window that goes from 0 to 2 pi, we're seeing sine cubed 2x twice. So that means the period is pi. Okay, as I said, we're going to come up with a pattern, whether this is an odd or an even number, what's really happening. Okay, so that's going to become easier. You're not going to have to play with it and try to figure it out. Okay, what's the period of cosine? 2 pi. So what's my least common multiple? 2 pi. Again, a lot of them are 2 pi, but they don't have to be. But 2 pi comes up a lot. All right, so now I need the whole thing. 3 sine 2x cubed minus 2 cosine x. Okay, and I know my period is 2 pi, so wherever it starts on the screen, it should end right there when we're done.
Whoa. Oh, it's going up.
Yeah, so we might have to set things
How do you get form higher or lower?
little higher, a little lower.
Try form the whole.
Sure, we could try -4 to 4. And you know you're seeing the whole thing if it ends
Going higher.
where it started.
Yeah, that's good enough.
So yeah, we're just about good.
You got all the X's in there.
Really forceful.
If they asked you for a complete window, okay, this is not a complete graph, but I'm just trying to find where it crosses 0. Okay, so how many times does that one cross 0? 6. Okay, what I'm going to do is, okay, we got 1, 2, 3, 4, 5, 6. Okay, I'm going to tell you what the answers are. Any question how you calculate them? All right, so the 6 answers are 0.50, 1.25, 1.57, 1.89, 2.65, and 4.71. Okay. And every answer would have plus 2 pi m. Okay, questions on that one? Questions? All right, so on that one, it is kind of a pain to find all 6, but you do have to find all 6 answers. Okay. All right, let's see if we can kind of figure out a pattern to these even and odds. Okay. It turns out that most of the time you end up using the formula when you have even powers, pi over b. That's how you find the period. Okay, where b is the coefficient of x in the argument. Okay, that's your b. Okay, so if you have sine to an even, cosine to an even, secant to an even, or cosecant to an even, all those use the formula pi over b. And for tangent and cotangent, it doesn't matter whether it's even or odd, you use the formula pi over b. Okay, the only time you use 2 pi over b is when you have sine, cosine, secant, or cosecant to an odd. Okay, if you can just remember the second part, sine, cosine, secant, cosecant to an odd, is this formula. Everything else is pi over b. And of course, we make b positive because we're finding the period. The period is a length of an interval. So it wouldn't make sense to say negative length. Okay, so any questions on how you find the period of any integer power for any of the 6 trig functions? Right, so you could tell me, oh, I have cosine to the 60th power. Well, I already know the period is pi over b, because 60 is an even power. Doesn't matter how high you go, just if it's even or odd. Okay, questions on it? All right, so I think that's kind of a nice summary to have in your notes. That way you don't have to think about it and try to play with the graphs each time. Right, so if we can solve trig equations graphically, solving trig identities is, or trig inequalities is pretty much the same thing. Okay? The only difference is our answers are usually intervals. Sometimes they also have like a union, okay, between this and this. Okay? And if we're solving inequalities and we're writing intervals, you have to put the plus 2 pi n or pi n on the interval as well. Just like we did on answers. We have to do that on intervals here. The only time you wouldn't have to put the plus 2 pi n is if they said find all answers between and they gave you 2 numbers. If they say find all, you got to put the 2 pi or the pi in. All right, so example 5, again, 2 ways we could do it. We could graph sine, graph cosine, and just see where sine, or cotangent, sorry, see where sine is less than cotangent. Or bring everything to one side and calculate roots. Right, so which way do you want to do it? You want to calculate intersects, or you want to do roots?
Intersect.
An intersect? Okay. So if we do it that way, I'm going to put sine in y1. Okay, what am I going to put in y2? 1 over tangent. And I am looking where the blue curve is going to be below the red curve. What's my period here? 2 pi. Okay. Period of sine is 2 pi. Think of it as sine to the first. It's an odd power. It's cotangent to the first. That's an odd power. So this is 2 pi. That's pi. All right, so let's set a window 0 to 2 pi. Okay, so we're looking where sine is below tangent, cotangent. So we're going to have to find that intersection point and that point. Okay, so let's find those first. Second calc intersect. Okay, that's about 0.91. Okay, we can write the whole coordinate. We don't really care about the y value. We care about the x value because the problem uses x. Okay, so 0.91 comma 0.79. Okay, and the second intersect. Does anybody have that one?
5.379.
5.38.
5.38.
And the y?
Negative 0.79.
Negative 0.79. All right, so how many sections are there where the blue is below the red?
1.
Where is the sine less than the cotangent? Think, Brian?
I believe that it's in the two sections, which is from 0 to 0.91, and not including 0.91, but then you do.
Yep, let's start with that. Okay, so I like that idea. From 0, which we can include because that is part of our window. And Brian didn't include 0.91 because it has to be less than.
0.91 is worth D.
Yes, yep. And now, let me give you a hint here, okay? What I would do is put this in. Okay, there's a vertical asymptote about, I think it's about right there. So we need to know where that vertical asymptote is. Well, one way we can think about it is our window is from 0 to 2 pi. It looks like it's right in the middle of the screen. So we could check if it's at pi. Okay, go to your table, type in pi, and we should get an error for the graph in red, and we do. Okay, so my asymptote is at pi. Otherwise, you just have to go back and look at your tangent again and remember where the asymptotes occur. All right, so where else is the graph in blue below the graph in red? From what to what? Yeah.
You could just put the and symbol first, and then put parenthesis pi, comma 5.3, or no, yeah, 5.38, and then put a parenthesis around that.
Yeah. So those are your two intervals where sine is below tangent, cotangent. Okay. Beyond that, it goes back above, and then it goes back above. And now, that interval from here to here, and from here to here, is going to repeat how often?
Every 2 pi.
Every 2 pi. So, for our interval, okay, what we should do, let me see how the book does it. Okay, so what they did is they wrote exactly what we have, and they said together with all horizontal shifts of these intervals, left and right by multiples of 2 pi. So I guess if we want to be consistent, we can write it that way, or we could just put a plus 2 pi n on each interval. Okay. So include above intervals and all horizontal shifts of these intervals by multiples of 2 pi. Integer multiples. That's how the book wrote it. So the above intervals and all horizontal shifts of those intervals by integer multiples of 2 pi. I'm fine if you just put the plus 2 pi in. That's fine. Okay, any question on that one? All right. Let's try this one, and I just want to graph it as is. Okay, what's going to happen here is we're not going to get, this is not a periodic inequality. Okay? What's on the left is periodic, but what about what's on the right? Yeah, it's just a parabola. Okay, so what's on the right is not going to repeat itself. Okay, so when we write the solution here, we're not going to need the plus 2 pi in. All right, so we're going to look where sine 2x is greater than or equal to this parabola. And you know what? Let me just make a small change. Let me make it a -1. I don't think the plus 1 is going to work out. Okay, and I'm going to do zoom 7. Okay, so there's the periodic sine 2x. I want to know where the curve in blue is above the curve in red. Find that point. Let's call this x1, y1. Find this point. Let's call it x2, y2. And where is the graph in blue above the graph in red?
x1, x2.
From x1 to x2. Yep. And does it say equal? Yep, we can equal. So x1, x2. Okay, you'd have to go through, calculate the intersect, and write down what x1 and x2 are. Okay, so I'm showing you an example here where you're mixing a periodic equation with one that's not. There's not going to be another interval because it's not like this parabola is going to repeat again over here. It's not periodic. That's the only answer. Okay, questions on that? That's an interesting question. We're not going to look at it right now, but it is kind of an interesting question. If you have a minute on your own, try graphing that and zooming in near the origin and look at what happens at some point. All right, the last one I'm going to look at with you is a double inequality. And basically, we're just going to graph in y1, y2, and y3. Okay, so just graph all 3 parts separate. And that's it. All right, so what I'm going to do is type in negative x in y1, type in x sine x, x sine x in y2, and x in y3. So I'm kind of looking for where something is sandwiched here. I'm looking for where, the way I did it in color, this is in, let's see, this one is in red. I'm looking for where the thing in red is between the thing in blue and the thing in black. Okay? So let's graph it. Just do zoom 7. Okay, and you know what? Let's zoom out a little bit. So I'm just going to do zoom 3. And what you're seeing there is a sine wave where the amplitude is constantly changing. Okay? Because the number in front is a variable. So the further away from the origin you get, the bigger it gets. Closer to the origin, it gets smaller. All right, so let's look at that. So let me put it here. So where is the graph in red above the graph in blue and below the graph in black?
Never.
The right side.
Oh, no, it's on the right
The right side.
On the right side. Yeah, on the right side, it's above the blue and below the black. So that's when x is what? Greater than 0.
Okay.
Or equal. It can equal here, so that's okay. Okay, so anytime x is greater than 0, there's our picture. Okay? Now, I want to take a look at B. And if you did it in color, if you don't do it in color, you actually are not going to be able to tell the difference between the two pictures. Okay? So watch what happens when we do B. Leave x sine x, okay, on y2, but type in negative absolute value of x. Okay, and also type in positive absolute value. What shape does absolute value look like?
Stairs.
You're thinking of a step function. Yeah, absolute value is a V shape. So one of these is going to be a V shape, and then one of them is going to flip that over and be like an upside down V shape. Okay, so there's our first part. There's our same x sine x again. And there's the second part. Okay, can everybody see the difference between the first picture and second picture? In the this one is your absolute value negative x. Positive x is the v going up. Okay, and the reason I said you couldn't see the difference if you did this in black and white, it looks like you have a V shape on the top and on the bottom, but with one of them, the V shape is formed by one function. In the other one, the V shape is a combination of two diagonal lines. Okay. So now where is this true? Yeah, this is always true. Okay. Where is what's in red above what's in blue? Okay, it's always above. Where is it below the black? Always. This is all real numbers. But as I said earlier, if you think these graphs are kind of neat, graph this. Sine 1 over x when you have time. And maybe we'll talk about it at some point. All right, so homework tonight is on 401. Okay, I want you to try 5 to 7, 11 to 15, 19 to 25, just the odds, 29 to 31, and 33 to 37, just the odds. Okay, we'll take a look at that tomorrow. We'll finish what we're going to do this week, tomorrow, which is section 7.4 on trig identities. And I'll be after school for extra help tomorrow as well.